Well, chapter 7 is going to be about confidence intervals. And we're going to do 3 sections. One, confidence interval for mean, a proportion, and a standard deviation. And we're actually starting with proportions. So the idea is that somebody might say something like this. I'm 95% confident that a proportion for the whole population is between 54% and 57%. I know people don't really talk like that, but I'm just trying to interpret the math into English. So it might be, perhaps they did a survey and said, are you satisfied with your job? And they found out that it's somewhere between 54% and 57% of people say, yes, I'm satisfied with my job. Well, if they did not interview everybody in the whole population, they can't be 100% sure. So based on some math that we're going to do in a moment, they could say, well, I'm 95% sure that it's between these two numbers. So we usually write the confidence interval like this using the decimal forms instead of the percent, and then the letter P for proportion in the middle. So it's saying P is between those two numbers. So you're probably wondering, where do those two numbers come from? So first of all, if we go back a ways when we first did standard deviation, and we would say that a score is unusual if it's more than 2 standard deviations from the mean. So that would basically be like saying, take the p hat minus 2 standard deviations, the p hat plus 2 standard deviations. And if you go out 2 standard deviations for a normal distribution, that's 95% of the data, so we could be 95% sure that it's going to be right. Okay, now we could be more accurate because we have table A2. Instead of just saying 2 standard deviations of the mean, we could say something like 1.96 standard deviations from the mean, or 2.33. So the interval is actually going to be p hat minus e and p hat plus e, where e, the letter E, stands for the error. So basically the p hat, you go out and interview 75 people, and 54% of them say that they're happy with their job. So there's going to be some error. So then you go plus or minus the error. So example number 1. Suppose there's an 8% chance of rain tomorrow, but my prediction could be off by 2%. So you would add 2% to get 10%, subtract 2% to get 6%, and so the actual percent is somewhere between 6% and 10%. That's what I just said. Thank you. All right, so what do we really need to do? Well, the E comes from this formula. So this Z, which is called Z sub alpha over 2, and I'll explain the alpha over 2 in just a minute, but the Z, that comes from table A2. And the P hat, you would be given that, or you just divide x by n to get the P hat, and then the Q is equal to 1 minus the P. So, as I said, we get the Z values from table A2, and here's an example. So these Z values are called critical values, and we're going to be using critical values from now through the rest of the class. So here's how you find critical values. So if it says use 95% as the level of confidence, that means that in the middle right here, that's 95% of the data. Then there's going to be a line over here and a line over here. And if I'm using 95%, then that means that there's 5% left over for these two tails in total. That's called alpha. Alpha equals 1 minus 0.95, so that's 0.05. Now because there's two tails, you have to cut it in half and put half of it over here on the left tail and half of it over here on the right tail. So that's why it's called Z sub alpha over 2. So let's see. I'm going to look up the negative one. So I'm using the negative z-score, and then I need to look for what's closest to 0.025. And then I'm searching and searching for it, and I hit the wrong key. There it is. So that means that, whoa, that's a big arrow. If you go to the left, it's going to be negative 1.9. And if you look up, it's going to be a 0.6 at the last decimal place. So in total, that means z sub alpha over 2 on the left side is negative 1.96. And then the good news is the other side is going to be the same number except positive. So those are the two critical values. Okay, example number 3. 1,000 Americans are polled, 413 say they approve of the job that President Trump is doing. And then create the 95% confidence interval. So here we go. I'm going to do the whole thing from the beginning to the end. So there's 1,000 people, 413 said they approve. So when you divide those two, you get the decimal 0.413. Then to find the Q hat, subtract from 1, and it's going to be a 0.587. Next up, we need to look up the critical values. So on this one, I'm using 98% level of confidence. That means 2% is left over, so that's the alpha. But in decimal form, 2% is 0.02. And then divide by 2, so 0.01 on the right tail and 0.01 on the left tail. Now I find it easier to look up the negative z value, and then I know the other one is going to be the same number but positive. So then I need to find what's closest to 0.01, and I think it's going to be right here. Let me see if the magic rectangle agrees. Yes. So that's going to be, oh, I forgot the arrows. Oh well, we don't need the arrows. So that's going to be negative 2.33. So negative 2.33 on the left side and positive 2.33 on the right side. So the error formula says take that z value and then multiply by the p hat and the q hat and divide by n. Take the square root and all of that becomes a 0.036. So what this is saying is about 41.3% of people say that President Trump is doing, or they approve of the job that President Trump is doing. But this estimate of 41.3%, it could be off by 3.6%. So finally, you add the 0.036 on the right side and you subtract it on the left side. And finally, I could be 98% confident that somewhere between 37.7% and 44.9% of people approve of the job President Trump is doing. All right, then on to the last example. Because right now you're probably wondering, I love all this theory part and drawing the bell-shaped curve and all that, but can we use the calculator? May we? So here we go. A survey of 104 children found that 43 of them watched some type of screen just before going to bed, even though pediatricians say that's not really good for children to do. Create a 95% confidence interval. And personally, I just call it TV because when I was growing up, it was TV. That was the only screen we had. So I just like to use the word TV even if it's an iPad or a phone or whatever. Anyway, make the 95% confidence interval. So you go to your trusty calculator, and when you go to Stat, then right there it's going to say Tests. Oh, I guess you can see it on the screen right there. And then go down to where it says 1 prop z int. So this is saying you have one proportion, because we're only talking about this one group of children. Proportion, because we're doing proportions in this section. And then the z just refers to that we get the critical value from table A2. But if you're using the calculator, you don't even need the table. All you need to do is tell it was 43 of them that watched screens out of 104. We're going to use 95. Make sure you put the decimal, 0.95 as the confidence level. And then it makes the interval. And so somewhere between 31.9 and 50.8% of children watch a screen right before going to bed. And that's it. Okay, then there's just one other thing that I wanted to do, and that is, what if you had the interval, and that's all you had? Could you find out what the p hat was and what the e was that make up this interval? Well, you sure can. So I'll show you with the little number line. So you just put the smaller number on the left, the bigger number on the right, and the p hat must be right in the middle. Well, if it's in the middle, that means it's the average of these two numbers. So just add them together, divide by 2. So that means that 0.413 goes right here, and that's p hat. Then the idea of making an interval is that you would take the p hat and then add the error to get this number, take the p hat, subtract the error to get that number. So what number was it? So you could do a little bit of algebra right here. So p hat is equal to a 0.413 plus the e. Then to solve for e, all you need to do is subtract 0.413 from both sides. And that would be the e. Okay, now we're done with this section.